morning. Today we're going to talk about reactions of alkenes. In particular, we're going to talk about additions across alkenes. So an addition is if I take my alkene and I react it with some reagent XY, then across my double bond X and Y are added, hence the word addition. It's the reverse of elimination. So in pink I have, basically, if I have a compound that's got an X group and a Y group on here, then an elimination is removing XY and forming the alkene. So in particular, the largest group of types of reactions in the addition category for alkenes is electrophilic addition. So essentially, what does that mean? We have an electrophile. It means that it loves electrons. Okay? And so the first step in an electrophilic addition is that my double bond, which we know is very polarizable, will actually attack my electrophile. And what you end up with is an intermediate. That's a carbocation. Okay, so that's the first step. The next step then is that if we look, how do I add the next part? When I take my carbocation and I add in my nucleophile. My nucleophile will be attracted my nucleophile, will be attracted to the carbocation. So my final product then will look like this. This being X, that being Y. So the first step, add my electrophile. Second step, add my nucleophile. So what kind of reactions are there that fall under addition reactions? Okay, so under addition reactions, we have what we call hydration. So just assume that we have our general alkene here, and if I add water, I'm going to add across my double bond in H and in OH. This is called hydration. Okay, that's the opposite of dehydration. Then what we have is we have hydrogenation. So you're adding hydrogen gas. Now that's not the reactant. This is just telling you what the XY is that I'm adding across. So just be aware that when we get down to the actual reactions, their conditions will be more precisely spelled out. Now, hydration, and this is hydrogenation. Hydration adds water. Hydrogenation adds hydrogen. Okay. This is called a hydroxylation. Essentially what we're doing is adding two alcohol groups across my double bond. And again, the actual details on how we do that will come later. I'm just showing you types of reactions. We can do an oxidative cleavage. We can do epoxidation. Okay. Good boy. All right. So let's take a look. Just so you know, this is the types of reaction. This is considered a reduction. This is considered an oxidation. This is considered an oxidation. And this is considered an oxidation. Okay, so we'll be going through these types of reactions. And let me continue and give you the rest. And I'll tell you which one we'll be doing first. Okay, so this is the first set of 5, and we have another 5 more to go. Add a halogen to form a dihalide. Okay. Add a halohydrin. Okay. It's called halo or halogen hydrin formation of the halohydrin. Okay. Just a regular addition of HX. Okay. This is called hydrohalogenation. Just move this over slightly. Okay. And I'm going to talk about adding proteins. This is called cyclopropionation. Okay. Of these, this one is an oxidation. Don't forget, halogens are very good oxidants. They get oxidized very easily, thereby reducing. Okay, so these guys get reduced. These are good oxidants. These guys get reduced and they oxidize basically the other substrate. This is basically also an oxidation. This is simply an addition, and this is simply an addition. Okay, so which one do we go with first? Let's talk about basically hydrohalogenation. Okay, so addition of hydrogen halides to alkenes. We're going to do this one first.